12.3 lesson is finding the determinants and the inverses. For the first part, it says determine whether the following matrices are multiplicative inverses. So there's a couple different ways that you can do this. We go ahead and type these two matrices into the calculator. They're both 2 by 2s. And then we're going to type the second one in matrix B. Alrighty, one way that you can tell is that if you go ahead and multiply these, so matrix A times matrix B, notice how the diagonals are 1 and everything else is 0. If we multiply this the other way, so matrix B times matrix A, then the 1s are diagonal. So if you get, when you multiply the matrices both ways, the 1's diagonal and 0's everywhere else, then it's going to be, yes, these are inverses of one another. If you don't get that, maybe the 1's are diagonal the one direction that you multiply them, but when you switch the B around, it's not, then it would be no. So it has to work A times B, the 1's diagonal, B times A, the 1's diagonal. Now, another way that you can do this is if we bring up matrix A, if we go to then this X to the -1 button, which is the fourth one down, we just click on that. That means the inverse of matrix A. So if we wanted to solve for the inverse of matrix A, we can then click enter. And then notice we get this second matrix. So then they are inverses of one another. And if we wanted to check this second one, we could go to second matrix, go to B, and then do that -1 button. Click on it. And then notice then we get the other one. So they are inverses of one another. And you can do the same for 3 by 3s, any square dimension. Alrighty, and the second part, it says evaluate the determinant. So I'm going to show you by hand and then also using the calculator. So how this works, you take the diagonal from the upper left to the lower right hand corner, and you're going to go ahead and multiply those. So 4 times 3. Okay, then you're going to subtract the diagonal from the upper right to the lower left-hand corner. Okay, and then you're going to simplify to get your final answer. Your final answer is just going to be a number, it's not going to be a matrix. So if we take 12 plus our 5, we get 17. Okay, and if we wanted to plug this into our calculator, we go to second matrix, go over to edit. We need to first always type in the matrix. Then if we go to second matrix, go over to the middle column. DET stands for determinant. So if we click on that and then go and type in matrix A so we know what matrix we want to find the determinant of, click enter, and then we get that answer. Okay, so if we go to this next one, when we have a 3 by 3, it's going to look a little bit different. So let's take a look at this one. So first thing we want to do, our first two columns, we want to rewrite them right afterwards. Okay, and then from here, we want to take our diagonals from the upper left to the lower right hand corner, just like how we did. And we're going to have then 3 diagonals, notice. And those diagonals, we want to go ahead and multiply them just like we did before. So if we multiply -1 times -2 times -3, and then take the next diagonal, 3 times 8 times 5, then the next diagonal, -4 times 6 times 7, and then with all of these diagonals, we're going to take the sum of them. Okay, and then from here, the next step that we did, we subtracted then the diagonals going the opposite direction. So then we're going to take all of this minus, and then we have to do the diagonals going the opposite direction. So we want to take the diagonals going this way and do the same. So we're going to take 5 times negative 2 times negative 4 plus, and then take the next diagonal, 7 times 8 times negative 1 plus, and then the next diagonal, negative 3 times 6 times 3. Okay, so then we have to take all of this minus all of this. And you can just go ahead and type it into your calculator. We get negative 54 minus, and then we're going to plug in everything on the right hand side. Okay, so this is how I would recommend maybe typing it in versus how I started, just each of the groupings in parentheses. And I get negative 70. The two negatives are going to end up canceling one another out to be positive. So then we have negative 54 plus our 70, and we get a total of 16. So notice for a 3 by 3, it's just a little bit same process, but it's just a little bit more work than what the 2 by 2s were. Okay, if we want to check our work for this one, we're going to type in the original 3 by 3 matrix into our calculator. Then we're going to go to the middle column. We're going to go to DET for determinant, and then we use matrix A, so have that highlighted, and then we get 16 for our final answer. Alrighty, the next part it says use the matrices to find the areas of the following figures. Express your answers in square units. So we want to find the area of this triangle. The equation for area of a triangle is a half times the absolute value of the determinant of matrix A. So how we get this matrix A, we're going to take each of these coordinates that are given to us and we're going to plug them in for these x and y values, and then the third column, notice, is just ones. Okay, so each of these three coordinates, though, we're going to plug in for the first two columns. We're going to have an x column and then a y column. Okay, so if we go ahead and take a look at this, we're going to have our area equals 1/2 times the absolute value of our determinant of our matrix A. So our matrix A is 2, 2, and 1 for this point, 5, 8, 1 for this next one, and 6, 4, 1 for this last one. Okay? And we always want to take the absolute value of it, because if this determinant ends up being negative, we can't have a negative area. So we always want it to take the absolute value of it to make sure that it's always positive. So we're going to type this into our calculator. So we're going to go to second matrix, go over to edit. It's a 3 by 3. Okay, and then we want to take the determinant of this. So if we go to second matrix, go over to math. DET stands for determinant of then matrix A we used. So click enter, and the determinant for this one was negative 18. So this we want to plug in, so we have the absolute value of negative 18 the absolute value is going to change it to positive. So we have a half times our 18, which is equal to 9. So our area then is going to be 9 units squared. Okay, again, if we would have just kept this a negative 18 times a half is negative 9, and we can't have a negative area. So the absolute value of ours is always going to allow that to change to positive. So we have a positive area. My hint for this one over here, this equation only works for the area of a triangle. So you're going to have to kind of make a line right here. Find the area of this triangle, and then add on the area of this triangle to it. So you have two separate triangles. Alrighty, the last type of problem in this section is, it says find the inverse of each of the matrices if one exists. So for this one, we can go ahead and type this matrix in. So if we go to edit, it's a 2 by 2. Once we have it typed in, go to graph clear, second matrix, have matrix A highlighted, and then again that x to the negative 1 power, it stands for inverse. That's a symbol for it. So if we click enter, then the inverse does exist. So that would be our final answer. We're just going to write 0.5, negative 1, and 3. If it comes up with an error message, then you know the inverse does not exist.